So we'll start learning the key features of Oracle Exadata. Oracle Exadata has around 7 key features as listed in this slide. These are named as Flash Cache, Flash Log, Smart Scan, also called as offloading, hybrid columnar compression, storage indexes, IO resource management. So these are the fundamental key features of Exadata storage server. These features are unique to Exadata storage server. These features are not found in third-party storage servers. That way, Exadata is unique compared to the regular storage servers. All these features, the aim is same. They improve the IO performance. Okay, except IO resource management, IORM. Okay, the all other features aim to improve your IO performance dramatically, so thus contributing the overall performance of the database. And all these features, okay, all these features except IORM, okay, except IORM are pre-configured out of the box. You don't need to do any additional setup. They are enabled by default. So that is another good thing. So that way you can take the advantage out of the box immediately. IORM you need to configure specifically. Okay. So let us start exploring all these features one by one. So today we will aim to complete Flash Cache and the Flash Log. There is some question. How are these different from 12C in-memory options? I know IORM is not available directly in 12C. The rest are available in 12C database. Rest are available in 12C database. Which all these features? No. See, in-memory option is different from these. Okay, these are storage server features. Okay, not database features. In-memory is a database feature, Oracle database feature. Okay, which is available from 12.1 O2 patch set. Okay, these are Exadata storage server features. No, HCC. Okay, I will tell you, HCC is a feature of Enterprise Edition database, but which is dependent on the underlying storage. Okay. If the underlying storage is Exadata, then only you can use a HCC. Otherwise, you cannot use a HCC. There are some other storages supported for HCC. Okay. So HCC is a feature of your enterprise edition of the Oracle database, which is dependent on the underlying storage. On non-Exadata platforms, you cannot use HCC. Okay. So effectively, you can use it only on Exadata and some other storage also, like Oracle has pillar axiom storage. Okay. On that also HCC is available. Oracle has FS1 storage server. On that also you can use. So we'll discuss. Just to wait for one more session. Tomorrow we'll talk about HCC. So today we'll start with Flash Cache and We'll aim to finish flash cache and flash log. So first, flash cache. So flash cache is a high performance cache on storage servers for frequently accessed objects. With flash cache, you can achieve massive throughput and IOs. Okay. In fact, inside Exadata, there are different memory storages used, like hard disk based storage, flash storage, and memory DRAM. Okay. So disk storage is good for storage, right? It can store a lot of data, but IO performance is less. Next to disk, you have flash storage. Compared to disk, flash is high performing storage. But again, it supports multiple IOs, but you can store a less amount of data compared to disk. And next to flash storage, you have RAM, DRAM, right? Compared to flash, DRAM is even much faster. But DRAM is compared to flash or hard disk, it is limited by capacity. So all the three types of storage with different performance characteristics are included in Exadata. All that you need to do is effectively use them by caching different data at different levels. Okay, so with that you can achieve massive throughput and IOs required for your OLTP kind of workloads. So we are going to discuss the flash cache, the middle one, okay, which is the flash storage. So flash storage, you know, every storage server, every Exadata storage server has flash storage, right? And this flash storage can be used for two different purposes. One is, on the flash storage, you can create grid disks, and these grid disks can be used to create ASM disk groups, so that you can create, you can store your table data. Okay, the way you store the table data on the hard disk. The second use is, you can use flash storage to configure flash cache and flash log to enable these features. And by default, the entire flash storage is used to configure flash cache and flash log only. That means these two features are enabled out of the box. If you want, you can drop a flash cache and a flash log anytime, and use the flash storage to create grid disks and ASM disk groups. Okay, so let us see the idea of flash cache. Now, look at this slide. This slide has database server and storage server, two layers. On the storage server, you have hard disks. Okay, hard disks. And on every storage server, by default, flash cache and flash log are configured. Compared to disk, flash storage is much faster. Now, on the database server, you have DRAM, you have RAM, and which has the buffer cache, right? Which has the buffer cache. Now, you know, Oracle database caches every block inside the buffer cache, right? And because buffer cache may be small in size, and it cannot hold all the blocks. Now, when a block is read from the hard disk, that block is cached inside the flash cache. Okay, and also cached inside the buffer cache in the SEA. Now after some time, the block in the buffer cache may be flushed out. Okay, in that case, the next query, okay, again has to issue IO request to storage server. Now the storage server, instead of reading that block from the hard disk, it will serve that from the flash cache, because earlier the block was cached inside the flash cache. Okay, so that way the storage server level, it is avoiding the physical disk IO, which is costly, right? And that is how the flash cache is used. So the flash cache is on the storage server, and it caches the recently accessed blocks of the table. Okay, and it is automatic. You don't need to do anything. Whenever you access a table block or blocks, those will be automatically cached inside a flash cache, and those blocks will be sent to the database server also, which are again cached inside the buffer cache. So now that way the flash cache is acting as a second layer cache for your database, which sits between your buffer cache and the hard disk. Okay, so that is the concept of flash cache and purpose of flash cache. The concept is understood. We'll discuss more details later, but first you understood what exactly is flash cache, where it is. Similarly, apart from flash cache, there is a small amount of flash storage used to configure flash log. So both flash cache and flash log are configured on every storage server by default. And compared to flash cache, flash log size is fixed. Actually, the default size is 512 MB only. 512 MB. Flash log is used for a different purpose, which we will discuss. Both will be configured. Okay, so now let us see. First time when a table block is read, okay, suppose that block is not present in buffer cache, not present in flash cache. Now the storage server has to read the block from the hard disk. Once after reading, it will cache into flash cache and serve to database server, where again it is cached into buffer cache. Now after some time, the block from the buffer cache is flushed out, right? So next read requires IO. IO is sent to storage server. Now Exadata storage server first checks for the block in the flash cache. If the block is present in flash cache, it will serve from there itself without doing physical IO. If the block is not present in flash cache also, then only it performs the physical disk IO. So that way the physical disk IO is reduced a lot on Exadata. Less disk IO means more performance. And the flash cache is very big. Okay, it runs into terabytes, you know, right? Each Exadata storage server has 12.6 terabytes of flash storage, right? So it is huge storage, terabytes of storage. So that means literally you can cache entire database inside the flash cache depending on the database size. Okay, and unlike buffer cache, flash cache is persistent. The data stored inside the flash cache is permanent. It persists whenever you reboot the storage server also. Okay, so that way, once the data is cached inside the flash cache, it may reside in the flash cache for longer time. When that will be flushed from the flash cache? Whenever the flash cache is full. Again, ESS uses LRU algorithm. The least recently used blocks will be flushed to disk. Till that time, the block will be present in flash cache. Okay, so chances are that a block may reside in flash cache for months together, years together. Okay, so till such time the physical I/O for that block is never required. So that way, by intelligently caching the data between all the three types of storage available, hard disk, flash disk and the DRAM, okay, the overall performance is improved. So let us see more details about flash cache. The flash cache, okay, can be configured in two modes: write through mode, write back mode. Like for database, you have log mode, archive log mode, no archive log mode. Similarly, for storage server, flash cache can operate in one of the two mutually exclusive modes: write through, write back. Write through is the default mode, okay, and the write through mode is best for random read intensive workloads. It is optimized for read operations. Write back mode is best for write intensive workloads. Means it is optimized for write operations. And the default mode is write through mode. You can configure write back mode anytime, and from write back mode you can switch to write through mode anytime. Default is write through mode, which is optimized for read operations. So if your workload is doing more reads than writes, maybe write through mode is the better option. If your workload is doing more writes than reads, then write back mode is better. So let us see both these modes, how they operate. Okay, and before that, it's not just a caching. This caching is available in many storage servers nowadays, right? Almost every storage server has caching mechanism. But what is different here is Exadata caching is very smart. Okay, it is intelligent. It knows what type of IOs should be cached and what type of IOs should not be cached. That way, there is some intelligence built into the caching algorithm. For example, this slide shows you what IOs are cached, what IOs are not cached. Okay. Frequently accessed data and index blocks are cached. Control file reads and writes are cached. File header reads and writes are cached. And these are all inbuilt. Even you can influence what to cache, what not to cache, what table to cache, what table not to cache. Okay, so that flexibility is in your hands. Then what type of IOs are not cached? Backup related IO is not cached. Okay, data pump IO is not cached. Data file formatting is not cached. Full table scans are not cached. Mirror copies are not cached. Okay, so by building the intelligence into the caching algorithm, okay, it knows which IO should be cached, which IO should not be cached. This is very different from the caching mechanism done by the third-party storage servers. In third-party storage servers, they cache everything. They don't know which type of IO Oracle database is doing. But because Exadata is Oracle, it knows what type of IOs Oracle is doing. That way, it has some intelligence. Okay. As I told you, you can influence the caching priority. You can choose to cache some tables to not to cache some other tables. There is one storage attribute, cell flash cache. Okay, no problem. There is one storage attribute, cell flash cache, and it can have three values: default, keep, and none, which allows you to keep the table and not to keep the table, or leave it to the default choice. So this slide shows you two examples. One is creating. While creating the table, you can mention storage attributes and say cell flash cache keep. Means the IO to this table is always cached. Okay. So later you can even alter a table to change the cell flash cache storage attribute using alter table. Okay, storage cell flash cache none. So that means now onwards any IO to this table will not be cached. Okay, so you are deciding which table to keep, means cache, which table not to cache. If you leave it to default, okay, so it will follow these mechanisms. So default is you are leaving it to the storage server algorithm. Then keep means you are influencing. Okay, you are telling you keep this table okay, in flash. And none means you are telling not to cache the IOs of this table. So this flexibility is with you. Now let us understand the internal details of write through mode and write back mode. As I told you, write through mode is the default mode. It is optimized for read IOs. Okay, reads are optimized. There are three scenarios shown in this slide. Okay. First, write operation. We will see the write operation. You have database server, you have storage server, and on the storage server you have hard disk and flash disk. Okay, hard disk based storage and flash disk based storage. Now the database server sends an IO request, a write operation. Okay, basically a write request to the storage server, which reaches the cell server process, right? So all IO related operations are done by cell server. Now the cell server writes this IO directly to the hard disk, not the flash storage. Okay. So that way the write is always directed to the hard disk. And if this table is eligible for caching, or before that, once the write is done, then it will acknowledge the database server. And later, if this table IO is eligible for caching, okay, this IO will be cached inside the flash cache, so that next read will be optimized. So that is how writes are handled. The important point is the write operation is always written to hard disk, then acknowledged back to the database server, right? Now next see read operation on previously cached data. Now again, database server wants to read the data. Okay. Now the read operation is directed to flash, not the hard disk, because flash is faster storage. Okay, your read performance will improve. Now the data block is already cached earlier, right? So it is already present in the flash cache. So from there it will serve the database server, right? So that way it avoided hard disk I/O, physical disk I/O. Okay, so definitely this read operation will be completed in quick time. Now let us see the third scenario where the data block is not present inside the flash cache. Okay. Now again the database server sends a read request. The cell server has to read it from the disk because it is not present in flash cache. Once it reads from disk, okay, it forwards that to the database server and also caches that block inside the flash cache if it is eligible for caching, so that next read operation will be again, okay, served by the flash cache. So that way all the read operations are optimized, whereas the write operations are directed to the hard disk. Read operations are directed to the flash storage. Similarly, write back cache. Again, write back cache is optimized for write operations. So that means any write operation will be directed to the flash cache, not the hard disk. Okay, because flash cache is much faster, your write operation will be much faster. Okay. So how it works? Write back cache, how it works? Or before seeing this, let us see the diagram. Again, database server sends a write request to cell server, and this write request now goes to the flash cache, not the hard disk. Earlier in this model, write through mode, that write request is going to the hard disk, not a flash disk. Okay, but here write request is going to the flash storage. So the write is written to the flash storage. Once the writing is done, acknowledgement is given to the database server. Because flash storage is much faster, the writing will be completed in a faster manner. So that way the write operation is optimized. Then at a later stage, okay, as required, this block may be written to the hard disk, okay, at a later stage. So that is how it works. Writes go to flash only. Data is automatically written to disk as it ages out of the cache. Right? So whenever this cache is full, then only the older blocks will be written to the disk. Otherwise, it need not even write to the disk. Active database blocks can reside in flash indefinitely for a longer time. Reads are handled the same way as in write through mode. Okay. Ideal for write intensive applications. For many applications, most I/O is serviced by flash. If a problem is detected, I/O operations transparently fail over to mirror copies of the data, which is also on the flash storage. So whenever writing is happening, right, because it may have to create a mirror copy also, because we have implemented ASM redundancy. So even the mirror copy is also written to flash. If there is a problem with the primary copy, it will write to the mirror copy. So this is how the write back algorithm works. Now, as I told you, you can switch from any mode to any mode at any time. Okay, this slide shows you how to enable write back mode and how to come back to write through mode. The default mode is write through mode. Suppose, assuming that we are in write through mode, which is the default mode, how to enable write back mode? Basically, you have to drop the flash cache with the drop flash cache command. Then you have to shut down the cell service and alter cell and set the attribute flash cache mode to write back. Then start the cell service and create flash cache. So now onwards, this flash cache operates in write back mode. Similarly, whenever you want to switch to write through mode from write back mode, these are the steps. First, you have to flush the flash cache contents, then drop the flash cache. Again, follow the same approach. You shut down the cell service, alter the cell, set the flash cache mode to write through, then start the cell service, then create the flash cache. Okay, so this is the procedure. Now, so as this is the concept behind flash cache. Now, you can monitor the usage of flash cache, how effectively the flash cache is being used inside the storage server. Without flash cache, how your performance? With the flash cache, how is the performance? In fact, we have hands-on lab exercises to do that. And once you do this hands-on, how do you verify the usage of the flash cache? There are some metrics and some statistics and wait events related to the storage server. You will use these statistics and wait events related to storage server throughout your lab exercises. Today, tomorrow, day after tomorrow, you will be doing many lab exercises related to all these features. And to verify their effectiveness, you use statistics and metrics. So this slide shows you some of the very important statistics that allows you to measure the effectiveness of all these features. Okay, basically you observe the blue font, blue ones. These are all the statistics, storage server related statistics, and these statistics can be queried from sysstat $systat view. Some statistics are displayed by $SQL view. Okay, and this is the typical query that you can run to get all these statistics. Okay, so basically all these statistics will have some sort of cell keyword in their name. For example, cell IO uncompressed bytes. Okay, then cell physical IO interconnect bytes. Cell physical IO bytes eligible for predicate offload. So that way, most of these statistics will have cell in their name. So any statistic that has cell keyword is obviously related to storage server. Okay. And apart from the statistics, Oracle has included some wait events also. Okay, we'll come to this. First, let us understand some of these statistics. Suppose, look at the third statistic. Cell physical I/O interconnect bytes. So what is the meaning of this statistic? The number of I/O bytes exchanged over the interconnection between the database servers and cell servers. Okay, so this metric will show you how many bytes are exchanged between database servers and storage servers. Okay, then yeah, some of these metrics will come in your AWR report also. In fact, many will come. Okay, if you don't run AWR report, you can run this query to see all these metrics instantaneously instead of waiting for your AWR report. Okay, then next metric, cell physical I/O interconnect bytes returned by smart scan. We will see a smart scan tomorrow. Okay, so what is the meaning of this statistic? The number of bytes that are returned by the cell for smart scan only, and does not include bytes for other database I/O. So essentially, this will tell you how many bytes are returned by smart scan. Okay, so that way you know the effectiveness of smart scan. For example, you executed a query. This metric, this statistic has 0 value. What does that mean? This query did not perform smart scan. Next query, okay, this metric showed you, okay, some okay, thousand number, means for that query 1000 bytes are, okay, returned by the smart scan. So that means for that query smart scan is utilized. So that way, using these statistics, you can understand internally what is happening inside the storage server. Okay, whether it is doing smart scan, if it is doing smart scan, how much I/O is processed using smart scan, okay, and how much I/O is sent from storage server to database server, all that. So these are very useful in measuring all these features effectively. So your lab exercises use many of these statistics every time when you run the query. Before running the query, we will see the statistics. After running the query, we will see the statistics. So that way you can compare the statistics before and after query execution and understand what is happening inside the storage server. Then sometimes some queries we use even wait events also. There are some wait events related to the storage servers, and again all these wait events, their names will have cell keyword in their name. Okay, so that means they are related to the storage server. So this slide shows you the important wait events and the description of all those wait events. So in some of the lab exercises, we even use the wait events to understand where the time is spent more inside the storage server. Okay. So this is about the flash cache. Any question on the flash cache part? So for flash cache, we have 3 or 2, let me see. Yeah, we have 3 hands-ons, 17, 18, 19. 17 is examining the use of flash cache using statistics. Just now we discussed the statistics. So you will practically monitor how flash cache is being used on the storage server with the statistics. Then you will configure write back mode. Then again you will configure write through mode. So these are the 3 lab exercises related to this topic. Okay, questions, clarifications?
Murli, Praveen here.
Yeah, Praveen.
Yeah, like flash cache is also made out of flash disk only.
Yeah.
Like when it reads from hard disk, it is a physical I/O. When you read from flash disk, is it not a physical I/O also?
See, both are IOs. Okay, both are physical IOs, but the flash is much faster compared to hard disk, right? So the IO performance is much faster on flash. So that way, your IO performance will be improved.
So next question. You said that almost entire database will be flashed in the cache. So in case of any incident, can we use this cache as like for any recovery? Does it help in any recovery if you don't have any control file or if you lost any control file? Can we use this area cache for recovery purpose?
No. See, it is for caching purpose. Okay. Instead of storing the frequently accessed data on the hard disk, you are storing inside the flash storage. But because you have flash storage, don't think you don't need control files, or if you lose control files, you can use this. The procedure is again same. If you lose the control file, what procedure you follow on non-Exadata, the same procedure we need to follow on Exadata also.
Okay. One more question. Already, like we enabled the default caching. We left to the Exadata server the caching part.
Yeah.
And you tried to cache a table which is already there. So then what it says?
I am sorry. Can you repeat the question once again?
No. What I mean to say, table X is already cached by default mechanism.
Table
so you
also
tried to manually cache the table once again.
It doesn't cache that. Okay, it will check that it is already in the cache, then it will ignore that.
Oh, okay.
Yeah.
One question regarding the startup process of RS, MS, and self-serve.
Yeah.
Like, is there any order for this process startup or shutdown, or yesterday when I tried to restart the RS process, once it timed out, and the second time it says it could not, the self-serve process could not respond, and the shutdown process is unsuccessfully the same.
No, actually you will use that service LD start, right? See, if you are restarting, better restart all the 3. Okay. Or if one process is down, whichever is down, you restart that.
Okay.
Okay.
Whenever I observe if you start MS process last, then it is doing successfully.
Yeah, actually internally there is some order for it. It will automatically start and automatically stop all these three services whenever you reboot the node, right?
Yeah.
And there is some order followed. First RS will be started, then cell serve will be started, then MS will be started.
Okay.
That is the order.
Okay.
Okay.
Okay. Thanks, Murli.
Yeah, sure. Any more questions? Otherwise, we will move to flash log now. Flash log is very small topic. Okay, just one slide only, not much. So now, by default, 512 MB of the flash storage is configured as flash log. That 512 MB is the default setting. If you want, you can increase, decrease that manually. Okay, but by default, out of the terabytes of flash storage available, 512 MB is configured as flash log. So what is the flash log concept? Flash log provides high performance, low latency, reliable temporary store for redo log writes. Okay, so flash log improves the writing of the redo log data. Okay, redo log records. Whereas flash cache improves the writing of your database writer. Okay, redo flash log improves your log writer performance, log writer writing performance. How? Now you see this diagram. For every transaction, redo data is generated in redo log buffer, which is in SEL. Now you know log writer writes the redo log records at various intervals to the online redo log files, which are on the hard disk, right? Redo log files are on the hard disk. And you also know redo log writing is a synchronous operation. Synchronous operation, which means till the redo log writing is complete, okay, the server process cannot continue with the transaction. Agree or not? So this might cause latency, right? This might cause latency on read affected systems, write slow systems. So how to improve the performance? That is where, okay, flash log comes into picture. So whenever redo record need to be written, the redo record writing is directed to the redo log files, which is on the hard disk, as well as the redo log, flash log, which is on the flash storage. Okay, and wherever the writing completes first, the acknowledgement will be given to the server process to continue further. Okay, so the redo writing is directed to the redo log files, which are on the hard disk, as well as flash log, which is on the flash storage. And wherever the writing completes first, the acknowledgement will be given to the server process to continue the transaction processing. Okay, so that is how the flash log is used. Log writes are directed to disk and flash log. Processing continues after fastest acknowledgement. Wherever it writes first, okay, it will continue from there. Conceptually similar to multiplexed redo logs, because the redo data is written to flash log as well as the redo log files. Okay, and Exadata storage server automatically manages smart flash log and ensures all log entries are persisted to disk. All log entries are persisted to disk. So because the flash log is small in size, 512 MB, right? So if 512 MB is full, okay, it will make sure this redo is also written to the hard disk before overwriting it. So that way it automatically manages the flash log. So that is the concept of flash log. Okay. So just to summarize, your flash cache improves writing of the database writer process or reading of the server process, right? That is the essence of that actually. Similarly, your flash log improves the writing performance of the log writer, because every write will be sent to hard disk as well as flash storage. And wherever the writing completes first, the server process can continue from there. So that way the waiting time is reduced, the log writer waiting time is reduced. So is this clear or any questions on this part? If no question, okay. I don't think there is any hands-on related to flash log because it is automatically configured, but you can drop the flash log anytime, recreate the flash log. You should have already seen some commands related to flash log in some of these exercises. For example, here, familiarizing with the flash storage topic. Okay, you must have come across some commands related to dropping the flash cache, flash log, recreating. Okay, list flash log details. Okay, this is the command which shows you the flash log currently configured on your system. So flash log size is 512 MB by default. Okay. Then in some other exercises, you will see how to drop flash cache and the flash log, reconfigure them. Okay, maybe let me show. In this exercise, right back, configuring write back flash cache. Here you are not dropping, but I remember some exercises has the commands related to flash log. Maybe here. Only list command is there. No problem. Okay. So whatever exercise you have, you practice them and okay, see how it works and all that. Okay. So that is the session for today. Any doubts you can ask me. Otherwise, we can continue in tomorrow's class. Okay. So once again, the practices related to today's topic are this one, 17, 18, 19. Examining the use of Smart Flash Cache, configuring write back, configuring write through mode. So tomorrow we'll continue and see Smart Scan, hybrid columnar compression and the storage indexes.